Hello and welcome back to MATLAB. Now let us discuss the next topic, which is identities, which you need to know to solve the last exercise of the trigonometry. So here are the three identities, which is sine square a plus cos square a equals to 1, secant square a minus tan square a equals to 1, and cosecant square a minus cot square a equals to 1. You can use a or theta. Here in this, theta is equals to. So the first identity, let us prove the first identity, which is sine square a plus cos square a equals to 1. Let us draw a triangle. So here is the 90 degrees. Let us name them A, B, and C. A, B, C. So the angle is at A. So this would be the opposite side. This is adjacent, and this could be the hypotenuse. We know that sine A, side's formula of sine A is opposite side divided by hypotenuse. Here the opposite side is BC upon hypotenuse is AC. In the given trigonometry, it's sine square A. You can write it as B square, BC square divided by AC square. And the next one is cos A. The sides formula for cos A is adjacent side divided by hypotenuse. What is adjacent side here? AB. Hypotenuse is AC. Then cos square A becomes AB square divided by AC square. Now here substitute the values. So what is sine square A? It is BC square divided by AC square plus cos square A is AB square divided by AC square. So we are solving the LHS part, which is sine square A plus cos square A. So the denominator is same. So let us write AC square and add the above numerator things, BC square plus AB square. We know that by Pythagoras theorem, hypotenuse square equal to opposite square adjacent square. Opposite square plus. So here the hypotenuse is AC square equals to opposite is BC square plus adjacent is AB square. So here you can see clearly that BC square plus AB square is equal to AC square. Now we can write BC square plus AB square as AC square divided by AC square. So both AC square gets cancelled. Now we are left with 1, which is RHS. So we used LHS part, and in the LHS part is sin square A plus cos square A. When we substitute the values, we got the RHS, which is 1. So therefore, the first identity is sin square A plus cos square A equals to 1. Sin square A plus cos square A equals to 1. So we have a technique to find the next two trigonometric identities. Let me explain you. So for this you need to remember one thing. So first divide the complete equation by cos square A. Divide by cos square A. Now divide both sides by cos square A. Sin square A divided by cos square A plus cos square A divided by cos square A equal to 1 divided by cos square. So we have mentioned to divide on both sides. So sin A by cos A. We know that sin A divided by cos A is tan A. And also we know that 1 by cos A is 1 by cos A is, let us substitute the values here. Sin square A by cos square A is tan square A plus cos square A gets cancelled. Now we are left with 1 equals to 1 by cos, which is secant. So secant square A. Now let us shift the tan square A to the other side. This becomes secant square A. When plus tan square A shifts to the other side, it becomes 1 minus tan square A equals to 1. This is second identity. Secant square A minus tan square A. The only thing that you need to do here is divide the two sides by cos square A. If you divide both sides by cos square A, then you substitute them, you will get the answer as secant square A minus tan square A equals to 1. Now let us solve the next identity using the same first identity again. Now let us use the first identity, which is sin square A plus cos square A equals to 1. Now let us divide the both sides by sin square A. Divide both sides sin square A. So sin square A divided by sin square A plus cos square A divided by sin square A equals to 1 by sin square A. We have divided both sides by sin square A, and we know that cos square A divided by, let us write it simply, cos A divided by sin A is cot A, and 1 by sin A is equals to cosecant A. Both sin square A gets cancelled. Now we are left with 1 plus cos by sine is cot. 1 by sine square a is cosecant square a. Now let us shift the cot square a to the other side. The plus becomes minus when we shift to the other side. So therefore the final equation would be cosecant square a, the plus here it becomes minus cot square a equals to 1, which is the third identity. Which is the third identity. So this is how you solve the three identities. So you just need to know the first identity, which is sine square a plus cos square a equals to 1. If you can remember that formula, then you can solve the other two identities. In the first scenario, we will divide the two sides using cos square, and you will end up getting secant square a minus tan square a equals to 1. Sine square a to divide on both sides for the first identity. From there we get cosecant square a minus cot square a equals to 1.